Hey, today we're going to talk about 4.6 watersheds. So take a moment, check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So a watershed is, in plain simple terms, it is the area that is drained by a river. That's it. It's the geographical area of land that is drained by a river. And there are some characteristics of a watershed. If you notice here, like the water right here, this is like a divide. This is one watershed. This darker green is going to a different watershed. So there's the river. There's smaller little tributaries, and a tributary is just a smaller river that flows into a larger river. Some characteristics. We have the area of the watershed. Larger watersheds will have more issues attached to them, especially when we're talking about pollutants. The length of the watershed, if it's a long river or short river. The slope of the watershed. A steeper slope is going to have a faster flow of water, which means there can be more erosion and more sedimentation in the river, and that can affect water quality. The vegetation types. If you have trees or grasses, they will absorb a lot of the runoff, and it can also be absorbing a lot of excess sediment, so you'll have less sedimentation in your rivers. And finally, the divides with other watersheds. So whatever these geographical features that are dividing one watershed from another, that can be something else that distinguishes the watershed. So sedimentation can be caused by the vegetation that's in the floodplain. And the floodplain is just the area of the river that encounters a flood. So when the river overflows its banks, maybe from melting snowfall in the spring or a heavy rain event, you'll have a floodplain, and that's the area that is where the river overflows. It can also be from the construction of a dam. So you can have flooding and you can have the construction of a dam that will lead to sedimentation. And this sedimentation can reduce the amount of nutrients downstream. To test that, you would always want to check upstream the nutrient levels and check the nutrient levels downstream. And you want to try to get, if you want to have a control, you want to see where there is very little impact from something else. So if I were doing a control of this river right here, I definitely would go in the main river somewhere upstream from this town. Somewhere upstream where it is just one source. And I would say up here would be a control group for this river. I could do something maybe here, because this looks like the city runoff is coming this way. If I went upstream a little bit, I don't know what's coming from over here. If that's picking anything up from the city, likely not. I definitely don't want to do any sort of control group from over here because it's going through this town. I definitely don't want to do a control group over here because it could pick up particles or sedimentation from the farmland. Okay, so a control group would be far enough upstream. Now, some impacts of a watershed. So the slope of the watershed is going to indicate the floodplain size. A flat watershed is going to have a very large floodplain, like in the Nile River in Egypt. A very steep slope is going to have a narrower floodplain. So that slope is going to affect the amount of runoff. And runoff can also be impacted by the vegetation. If I have more plants, more grasses planted along a riverbed, I can have less runoff from that river. And the size of the floodplain is going to indicate the amount of nutrients that are available. A larger floodplain is going to pull in more nutrients. That can help impact crop production, but also can indicate the amount of productivity at the delta. The delta is the area at the end of the river where basically it drops off all the sedimentation. If you look at the Nile River, the Nile flows north. Up near like Cairo, there is a delta from the Nile. If you look at the Mississippi River, where the Mississippi drains down in the Gulf Coast, there is a delta, and that's because it just keeps dropping off sediments. Because of the runoff, you can have large amounts of erosion, and that can be, again, because of the slope and the vegetation that is found in the floodplain. And that erosion can lead to habitat destruction, which then can lead to biodiversity loss. Now, if we use fertilizer use, and that fertilizer runs off, That can lead to eutrophication. Remember, eutrophication leads to an algal bloom because there's a big influx of nutrients. The algae increase in population. The algae use up all the nutrients. They die. When the algae are decomposed, the bacteria and the decomposition process uses up all of the oxygen, leads to hypoxia, and that can lead to biodiversity loss from the fish kills. Now here's a map of the watersheds in the United States. And I just want to point out that there are watersheds within watersheds. So we have right here the Ohio River. We have right here the Missouri River. And in fact, the Missouri River is just slightly shorter than the Mississippi River. But the Mississippi River is considered the largest river in the United States because the Missouri River flows into it. But literally they're like neck and neck for the sizes. But this is considered the Mississippi-Missouri drainage basin, even though the Ohio River is another major river in the United States. And it's funny because this is where I am originally from. I am literally very close to the start of the Mississippi River, maybe a half-hour drive. And I'm also close to this Red River of the North, and this will eventually drain into Hudson Bay. And if you look at a map, Hudson Bay is the part that like juts down. It's the water that juts down into Canada. And, you know, just a few miles away, the water would flow down to the Mississippi River. So I was actually on the borderline between two watersheds. So this is, again, a major impact because whatever is done up here in the upper Midwest will impact the productivity and the river water quality in the southern United States because of the flow of the Mississippi River. So keep that in mind, that we really want to pay attention to our entire watershed, not just the individual rivers. So for FRQ practice, I would like you to describe how topography can influence the water quality of a river in a watershed. So take your time right now to formulate your response. I appreciate your attention and thank you. I will see you soon.